At the end of the Mesozoic, we began to see some strange animals appearing. Mammals, tiny little creatures, creatures that survived in the understory of life. And we see the demise of the dinosaur at this point. And again, we think it was an internal object. It was an object in space, meteorite, comet, whatever the case may be, contaminating the atmosphere, killing off the food supply of the dinosaur. The dinosaur was not only a primary consumer, but a secondary consumer. And as soon as you shut off the food supply of that organism, it's not going to survive very well. But rats and mice and things of that nature can survive on limited food. And that's why the mammals are coming into play. I'm not saying there are rats and mice, but just think of the small amounts of food that these organisms needed. So we leave this time period and we go into the current time period. And the mammals have become now the dominant species. Dominant animal type, not species, animal type. We still have our amphibians and reptiles and fish and birds and so on. But these now are the top of the heap as far as the organisms living on planet Earth. And we don't make a scene until late Cenozoic. Well, the use of terms early and late. Early Mesozoic is at the beginning. Late Mesozoic is here. Early Cenozoic is 63 to 67 million years ago. Late is current. So the term early and late, the beginning is the early, the last end is late. And again, Pleistocene, Pleistocene. Pleistocene is about 2+ million years ago. Relatively recent in geologic time. At that point, at that time, your immediate ancestor climbed out of the trees. In the savannah, in all likelihood. And took on the big lions and tigers and survived. Anybody happen to read Science News lately? Not a big reader? Science News had an interesting article saying that 2 to 3% of our DNA can be traced back to Neanderthal. So apparently Homo sapien was messing around with Neanderthal, or the other way around. But there is some indication that there is Neanderthal DNA in all of us.
Yeah, I heard about that.
So next time you see the guy dragging his knuckles on the pavement, odds are he is maybe a little more Neanderthal. Okay, so Pleistocene is when we make our appearance in the last ice age. That which modified most of Wisconsin started at that time. No relationship between the two events. It just happened to be at about the same time. So the last ice age, Pleistocene. Okay, if you were to see this on a test, what would I ask you? I would ask you major life forms at each stage of the way and roughly the time frame. So no life, basically aquatic life blooming onto land, introduction of amphibians, reptiles, then birds and dinosaurs, and then mammals at the end being the dominant life form. And then during the Pleistocene, it's us. So that's the aging process. Now let's look at our all of you have had high school chemistry, right? All of you have had some college chemistry.
Nope.
Okay, well, okay, we'll settle for high school chemistry. We're not going into subatomic particles. neutrons, electrons, and protons. We're not going to do that. We're not going to go into charged particles, ions, cations, and anions. We're going to skip that step and go into the next element, the next building block of planet Earth. So we start looking at building blocks. Start off with, first of all, the elements. That's where you're dealing with subatomic particles. We're not going to go there. If you want to know the elements, look at a periodic table. The two most common elements on the Earth's surface are oxygen, about 47%, and silicon, about 28%. So about 75% of the elements on the Earth's surface are these two. And if you combine these two, we end up with something called silicon dioxide, SiO2. SiO2 is what? I know, silicon dioxide. It's quartz, which is the most common, next building block, mineral. So, now the other major elements, there are only two other major ones really, aluminum and iron, but they're both in the single digits. So these two, silicon and oxygen, make up the bulk of the Earth's surface. And quartz is the most common substance because most sand that we have is quartz. But sand is, remember, a size, not a substance. But most sand is composed of quartz. Okay, so we start with a building blocks called the elements. We put elements together, we end up with minerals. What's a mineral? First of all, it occurs naturally. So it occurs naturally. It's naturally occurring substance in our environment. Two, it's inorganic. Can't be plant or animal remain. My question to you is carbon an organic substance or inorganic? It's what? Okay. Carbon itself is inorganic. Coal that we see has a high carbon content. But diamond is almost pure carbon. In fact, the chemical composition of diamond and coal is very, very close. So if you're really a cheapskate and you want to give your beloved a carbon stone, stay away from the coal and go to a diamond. You impress them a whole lot more. But you can get a bigger piece of coal for the same price you pay for that diamond. But they're basically carbon. Okay, so it's naturally occurring, it's inorganic, limits of physical and chemical characteristics or property. So it has limits, a range of properties, both physically and chemically. So a mineral may have slight variation. That's why diamonds are typically clear, but what other colors? A yellow diamond is possible.
Blue.
A pink diamond is possible.
Blue.
A little bit of impurity.
Yeah.
How about opal? What color is opal? Okay. If we start at the low end of the opal, it's a milky color. And then if you go higher, you end up, again, impress your friend, a black opal. Black opals are what you want to do. But remember, opal is very, very soft. It's not intended to be used in a dishwasher and things of that nature. So limits physics, and it's a solid. So again, it has crystalline properties. Solids have crystalline properties.